Wait, hold up. Alright.
Hello, my name is Samuel Musser.
I'm Ann Yates.
I'm Sarthak Sarin.
I'm Michelle Yang.
I'm Jang Liu.
And we're Ray's Pizzabase.
Okay. Our team intends to create a database for Ray's New York Pizza restaurant. Ray's is a local restaurant tech square that all Georgia Tech students, and especially Scheller College of Business students, love to go and dine at. We have chosen this restaurant because not only does Scheller use it for catering, but also, as I said earlier, we all love to go eat there. From pizzas to Mediterranean fare to appetizers and entrees, everyone loves to go to Ray's, and they are in desperate need of a database.
This is a real life project, and one of our group mates went to go talk to the manager at the Ray's Pizza, and he told us that they didn't have a database. And so our main purpose for this application is to help the managers and employees kind of manage their orders of their customers. So we're looking at dining options and also employee tasks, and also how that can be transfigured together to make a good database for their managers and employees to use.
And now to our ER models.
Our first entity is employee. We have a primary key of employee ID and a few other attributes to determine who the employee is and their wage. So for example, we put employee start date. That actually determines the employee wage, and that's why we have that as a derived attribute. And then we have other attributes to determine the employee and to call them about their shifts. To also display managers, we had employees have a unary relationship amongst each other. Moving on to customers, employees and customers have a many-to-many relationship. So a customer can be served by one or many employees, and an employee serves one or many customers. A customer has a customer ID. In order to contact them, we also put a customer phone number and customer name to also give them coupons and just basic advertisement. Moving on, we have orders. There is so for orders, we have order ID and order date for their primary key. It's a composite primary key because they reuse order ID per day to determine that specific order. We had order date so that together they can actually uniquely identify that order. And then last but not least, we have a many-to-many relationship between orders and employees. So an employee fulfills one or many orders, and an order can be fulfilled by one or many employees.
Based on the Ray's Pizza menu, we have two different types of orders, which is catering and dining. For the catering, the customer will know the price determined by the catering menu item and the party size. We have a relationship here where each catering contains one and only catering menu item, and each catering menu item is contained by one or many catering orders. And for the customer choosing the catering menu item, they'll choose specific meal choice name, which, for example, we have bean feast or pizza feast. And for the dining, the customer will know the price because they have the fixed price for each specific menu items. So the relationship here is that each dining order will contain one or many dining menu items, and each dining menu items will be contained by zero or many dining orders. And we put the dine-in on the to-go order in the same entity, and then we differentiate it by the table ID. If it's a to-go order, then we'll put the table ID in a no value.
So the next part in creating a database is converting our ER diagram into tables. So from our ER diagram, we got 10 tables. So we had 7 entities, and the 7 entities are the cheese slices of pizza, and then we had 3 many-to-many relationships that got converted into tables, and those are our pepperoni slices. So we're going to focus on the many-to-many relationships. So we have employees and customers having a many-to-many relationship where one employee can serve multiple customers and one customer can be served by multiple employees. So that is our customer-employee table right here. And then we have employees can fulfill many orders, and orders can be fulfilled by many employees. So that's our second many-to-many relationship table. And then our third one is table order, which is a relationship between our dine-in entity and our dine-in menu item entity. So at one table, your dine-ins, you can have many items being ordered in one dine-in order, or you can have one dine-in menu being on 0 or many dine-in orders. So whenever a new item is released, there's a possibility it's never been served on a dine-in order, so that's why it's a zero-to-many relationship there. And so that is our last many-to-many relationship, our table order table. And that's about it. So we hope that these tables can make an impact on the database that we're building for Ray's Pizza, and it'll help their company in the future.